Hello.
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 Hello,
Ma'am,
everyone.
we are going to revise week 1 to 6, right?
Yeah. So uh, just wait for 2 minutes, then we will start. Uh, okay. Good evening, everyone. I hope you are able to see my screen. Am I audible?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
Yes.
ma'am.
So, as you all know, this is going to be the revision session for week 1 to 6, probably. So, let us start. Okay, someone has wrote that not visible yet. So yeah, can you see it now?
No, it's visible. It's
Okay, okay, okay. Okay, so we can start now, right?
Yes.
Yeah. So what was the content for week 1? In week 1, we studied about the number system, right?
Yes.
Yes, ma'am.
So here we consider the set of all natural number from 0 to infinity, right?
Yes.
Then we know what about z, which is from minus infinity to plus infinity, not open interval. Sorry. Then q, which is in p by q form, right? Where pq belongs to z and q not equals to 0. Then we know about real number, about irrational number, right?
Yes.
Yes.
After that, we define what a set is. So any one of you, can you assist? What was the definition for a set?
It's a collection of different
Collection of data.
Well-defined collection of something.
Yeah.
Yes. The word well defined is important here. You have to mention it, okay?
Yeah.
Well defined collection of objects. This underlying word is really important. You cannot miss it, okay? So a set is basically a well defined collection of objects. And this all the set, these are set, right? The natural number, we can call it the set of all natural number, the set of all integer, and so on. Okay, these are examples of sets. So then we know what the set operations, right? Union, intersection, subtraction, cross product, right? So what was the set union? Suppose we have A equals to 1, 2, 3, B equals to 3. If you want PDF mint, I think you want PDF of this session. If you want, I will share it with you in the chat box. Okay?
Okay, ma'am.
Yeah. So what will be the union? Anyone? You
Ma'am,
have to give
1,
answer.
2, 3.
6.
1, 2, 3,
Yeah, 1,
6.
2, 6.
1, 2, 3,
1,
6.
2, 3, 6.
So it was union and intersection. What was the
2 and
intersection?
3. 2 and 3.
Right.
2 and
2
3.
and
2 and 3.
And difference? What was the difference?
1 and 6.
1.
1 and
One only, right? And
Yes.
what about this one?
And 6.
6.
6.
Right.
6.
Yeah. And what is A cross B? All the pairs, all the tuples, right? All possible
ma'am.
tuples. So you all know about all the set operations, right?
Yes, ma'am.
Yes, ma'am.
So you are now comfortable with the set operation. Then we defined relation. Fine. Simply, what we can say, a relation is subset of A cross A, right? Relation on A. It's a subset of A cross A, right? So we will
Yes.
pick some ordered pair from A cross K, A cross A. And whenever AB belongs to R, we will say that A is related to B, right? Right? It was our definition. Then we know identity relation, right? So identity relation was formally, basically, whenever AB such that A equals to B, right?
Yes.
Whenever AB belongs to R, it will imply that A equals to B. And then we have reflexive relation, right? Which is A comma A belongs to R for every A belongs to the set A, right? So now you have to tell me what is the difference between an identity relation and a reflexive relation. Any one of you can unmute yourself. And
मैम diagonal element बराबर होना चाहिए.
so what is the difference? In
Ma'am,
order to
like in
define the
Can you
identity
pardon the
relation.
question?
Mhm.
Can you repeat the question once?
Yeah, what is the question is what is the difference between an identity relation and a reflexive relation?
And the
ma'am, in
identity relation is a
relation-
subset of the reflexive
Only
relation.
one by one, please. Yes.
Ma'am, like in
And the
identity relation, that will- okay, you continue.
And the identity relation is a subset of the reflexive relation. And in identity relation, we only have the pair means A, B, B. And in reflexive, we can have A, B and A, B, B also.
Yes. Right.
Right.
Identity relation is a special type of relation where reflexive relation is a property of that relation.
Okay. Yeah. So that means let me summarize what you have already said. If we have a set A 1, 2, 3, then we can define a relation like that. And also right? Both are relations over A, right?
Yes.
Yes,
ma'am. The first one is
Identity.
Identity relation.
Identity relation.
identity and reflexive too, right?
Yes, ma'am.
Yes, ma'am.
But the second one is not identity, right?
Yes.
But it is reflexive,
Reflexive.
right? So you know the difference between identity relation and reflexive relation.
So ma'am, it's like the reflexive relation can be identity relation, but identity relation cannot be a reflexive, right?
may not be, cannot be, no, may not be. Okay. If it is identity, then it will be reflexive. Because for being reflexive, we want these three elements in the set.
Right,
There
ma'am.
can be element other than that, but these three elements is mandatory. So if a relation is identity, then that will imply that it is reflexive. That means identity relation implies reflexive, but not the converse. Okay.
Okay. Okay.
So
Got it.
relation is reflexive, that may not be identity. Okay. So
Okay.
it is relation between reflexive relation and identity relation. So it's now clear, right?
Yes, ma'am. Yes, ma'am.
Okay. So now let's come to symmetric relation. So what was the definition for symmetric relation?
Ma'am, if A is equal to B, B is there, then B A should be there.
Right. Very good.
Yes,
So if AB belongs to R, it will imply that BA belongs to R2. Right? It was the definition for symmetric relation. So what we can we make any comment about R2, whether it is symmetric or not?
Not symmetric.
Yeah, because 2-1 is not in R2, right?
Yes. Yes, ma'am.
Yeah. So suppose we have something R3, 1, 1. So is it reflexive? Sorry, is it symmetric?
Yes. Yes, ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
Yes, very good. Because this condition is not necessary for all elements in B. If AB is there, then we will think about BA. If not, then this is not our case of concern, right?
Yes.
Then we know about transitive relation, right? What was the definition? If AB belongs to R and BC belongs to R, then it will
Then
be
AC also belongs
to R.
Yeah, right. Very good. Then AC belongs to R, right? So yeah, R2 and what we can conclude from R2 and R2 is R2 transitive?
No, ma'am. Not transitive.
Mhm. Is R2 transitive?
No.
Why? When you are saying no, you must have some example in your mind, okay?
Ma'am, it is not transitive as 1, 2 don't have an image like
2-1
right?
isn't present, that's why it isn't.
Like ma'am, like okay, wait. Let me
We
see.
don't have for 2 and 3, ma'am.
Ma'am, 3 is
Don't have
considered as
yes,
a
ma'am.
C,
R2 is transitive.
Ma'am, 3 is considered as a C. So 1 and 3 is not there. So that is the reason.
R2 is transitive, ma'am.
Yes, ma'am. It is transitive.
It's a transitive.
Ma'am, 3, 2 is not
Yes.
present. No, yeah.
Do you need
It
3
does
to
not matter because it is not already present now.
Yes,
Do we
yes,
need-
ma'am.
What was our condition? If AB and BC in R, then we need to check for AC, right?
Yeah.
So here we have
Yes,
1,
ma'am.
2, which is AB. Again, we have 2, 2, which is BC. So what is our AC? It's again 1, 2, right?
Yeah.
Yes.
And 1, 2 belongs to R2, right? So it
Ma'am,
became a
excuse me, ma'am.
transitive relation, right?
Ma'am, excuse me.
Yes.
I just take that 1, 1 as AB, then BC will be 1, 2, then again that 1, 2 will be in AC, ma'am.
Yes.
Okay,
So 1,
thank
2
you.
is in the set.
Okay, thank you.
So R2 is transitive, right? What about R3?
It is transitive too, ma'am.
It's also transitive.
No, it is
Why?
not transitive, ma'am.
Ma'am, it is transitive because as we see 1 1, then there will be also a 1 1 available. So I think it is identity relation is always transitive. I think so it was the rule.
It is transitive.
Yes, ma'am, it is transitive.
So R3 is also transitive. Okay, so let us look at some other example. Again, I'm taking A as
Ma'am, like, sorry to interrupt. I couldn't understand why this R3 is transitive.
okay. You have to follow up the rule, okay? What is the
Right,
rule?
ma'am.
If AB and BC belongs to R, right? So let us start with this element. This is our first element. Suppose this is AB, right? Is there any BC? Like, is there any element for which the first coordinate is 1? No, right?
Yes, ma'am.
No,
So
no, it is not.
we need not to be bothered about it. Similarly, if we take this element, this is our AB. Again, there is no element which starts with B. That is 2, right? So we don't
Yes,
have
ma'am.
any
Okay.
BC. So we don't have this condition. If this condition holds, then it will imply AC belongs to R. But if we don't have any type of thing, AB and BC belongs to R, then we need not to check that whether AC is in R or not. Okay.
Okay, so like how it can be transitive, ma'am? Actually, that's the issue.
Because this is not mandatory for all the element. If it is the case, then we have to check whether AC belongs to R or not. If
Right.
it is not the case, then we need not to check. Okay.
So, ma'am, like this relation will fall into identity relation, right?
No, this is not
It is
even
the-
identity relation because 3 is not in the set. In order to be
Okay.
identity, 3 should
Right.
be in the set, right? It is not identity, even it is
So-
not reflexive.
So suppose you add 3, then how will you prove that this is a transitive relation?
Ma'am, but 1 2 isn't present, so how is it transitive?
Ma'am,
If we
We
can't
have
check for
only
transitive,
1 1
then
and 2
it is
2,
assumed
right?
to be transitive.
What? Can you repeat?
If we can't check for the transitive condition, I mean the two condition does not satisfy, then it is assumed to be transitive.
Yes.
ma'am, why only transitive we
Not
assume? I mean,
assume. Like suppose we have 1 2 2 1. Okay.
okay, ma'am.
In that case, we have AB, we have BC,
Okay.
but we don't have AC, which is
Yes,
1 1.
Okay,
So this is not a transitive.
clear.
Clear?
Yes, ma'am.
Yeah. But here, in this case, R3, we don't have AB and BC. So you need not to check for AC.
So,
Right?
ma'am, here you must correct the notations. You have noted the 1 also as B and 2 also as B, which is creating confusion.
Yes, ma'am, that's the actual problem.
Mhm.
I mean, I'm not
So
getting
in case B, yes. Okay, so
um,
I use this for just to just to explain. Forget about this. So if this happens, then this will be in the set. This is the condition. Okay.
okay,
So now
ma'am.
you can ask if you have still any doubt.
No, ma'am.
Let us
All clear.
yeah, let us check with some other example.
Okay, ma'am, sure.
Yeah. So what is the conclusion for R4? Is it reflexive?
No, ma'am.
No, ma'am, it's not.
Because
No,
2 2
ma'am.
is not in the set, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Is it symmetric?
No, ma'am.
Why?
No, ma'am.
Because
No, ma'am.
3-1 is not present.
3-1, then 3-1 has to be there.
Yeah, 3-1 is not in R4, so it is not symmetric. Is it transitive?
Yes, ma'am.
Yes,
Yes, ma'am. It's a
Yes,
it is true.
So it
yes,
is
ma'am. It is transitive.
because we don't have any example which contradicts the definition, right? If we are saying a relation is not transitive, we must have some example in our mind which is contradicting the definition, right? Here we don't have any kind example. Like if we start with this element 1, 3, this is our AB, suppose, then we have 3, 3 as our BC. So again, our AC will be 1, 3, which is in the set, right?
Yes, ma'am.
Yeah. So we can start with this element 2, 1, 1. Suppose 1, 1 is our AB and 1, 3 is our BC, right? Then what is our AC? 1, 3, which
1,
is
1.
again in the set. 1,
Yes,
3,
ma'am.
right?
But ma'am, you count twice 1, 3.
No, not necessary, Prabhat.
No. You don't need to take twice. One, like if you take it one time, it is enough. No problem.
Like you say 1, 1 is there, and then you say 1, 3 is there, right? So
Yeah.
there must be 3, 1.
Why? In order to be symmetric.
In order to transitive.
1, 1 and this in the relation, right? So this is our A, this is our B, right?
Yes, ma'am.
Again, this is our B, this is our C, right? What is AC? What is
1,
AC?
3.
1, which is in R4, right?
Okay.
Yes,
Got it.
ma'am.
Okay. So I got it?
Yes.
Okay, let us take. Yeah. Is it reflexive?
No, ma'am.
No, ma'am.
Why?
1, 1
We are
is
missing
not.
3, 3.
No, ma'am, it is not.
1,
3 is
1 and 3,
1,
3
1.
is also not.
3, 3,
1,
1, 1.
1 and 3, 3 is not in the set. Is it symmetric?
Yes.
No.
No, ma'am. No,
1,
ma'am.
2 is missing. 1, 2 is missing.
Right.
1, 2 is
Then
not
it
present.
needs
1, 2 to be
is not present.
Is it transitive?
No, it
No, ma'am.
is not.
no.
No, ma'am.
No.
2, 3 is missing.
No, ma'am.
2, 3 is missing.
1, 1 is also missing.
Yes, ma'am.
3, 3 is also.
Okay. 1, 1 is missing.
2,
Someone
3 is
will
missing.
take 2, 3. So why are we taking 2, 3?
If we are taking 2, 1 and 1, 3, then we need 2, 3 to prove it as a transitive.
Okay. Yeah. Right. So yeah, 2, 3 is also missing.
Yes, ma'am.
Basically, ma'am, we need one to contradict it is not transitive.
Yes.
Right?
Yeah.
Oh.
If we want to contradict some like the definition, the hypothesis, then we need just one example. If we are not able to find any example, then it is transitive. Okay.
Okay, ma'am.
So
Ma'am, this will be transitive, right?
yes. Can you repeat?
And this one will be transitive, right? R5.
No. We have example, right? This 2 belongs to R5, but 2, 3 is not in R5. So our AB and BC in R5, but AC is not in R5.
Ma'am, but 2, 2 and 2,
Contradicting.
1.
But we can find one example, right?
Yes.
If there is one example which is not satisfying the condition for being transitive, then we will imply that the relation is not transitive.
Ma'am, R5 is not transitive, no?
Yes, not transitive.
Okay, ma'am.
Clear?
Yes,
I
ma'am.
think some of you may have confusion till now. So let us discuss one more. R6. Suppose okay, so yeah, is it reflexive?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
it
ma'am.
is reflexive.
Yes, ma'am. It is
It is
reflexive.
reflexive, ma'am.
Yeah. So you don't have any kind of confusion with the reflexivity, right? So you're
Yes.
all
Yes,
of
ma'am.
you are clear with reflexive. Is it
Yes, ma'am.
symmetric?
No,
No,
ma'am.
ma'am.
Why?
No, ma'am. 2, 3 is missing.
3, 1
3,
3,
1
1
is
is
missing
present.
and 3, 1 is also missing.
2, 3 is missing. 3, 1 is missing.
Right, right. Very good. So it is not symmetric. Is it transitive?
Yes, ma'am.
Yes,
No,
ma'am.
ma'am.
No, ma'am.
Not transitive. 1, 2 is missing.
Not transitive.
1, 2 is missing, ma'am.
So we have 1, 3,
Yeah, 1, 2 is
3.
missing.
But
Yes, ma'am. 1, 2 is missing.
this doesn't belongs to R6. So this is not
1,
transitive.
2 is not in transitive.
Yeah. So is it clear to everyone? If still
Yes, ma'am.
anyone
Yes,
Clear.
ma'am.
has yet with
Hello,
any
Yes,
ma'am.
ma'am. No doubt.
Hello, ma'am. In this relation, if there wasn't 3, 2, then it would be transitive, no?
if we remove what?
3, 2.
3, 2.
The last element,
3, 2. Yeah.
then it would be transitive, no? Because we
Yes.
can't check the transitivity.
Yes. 1, 3, we can check, but it is satisfying this because if we just remove 3, 2, there is 1, 3 and 3, 3. Again, we have 1, 3 as AC, right? Which is in the
Okay, yes, ma'am.
it's fine.
We can also take 1, 1 and 3, 3 and we will get 1, comma 3. That way is also possible.
What? 1, 1 and
3, 3, 3 if we take, then also we'll get 1, comma 3.
how?
That will also make a transitive.
No. Yeah. This will be transitive.
Yeah.
Ma'am,
Yeah,
actually,
That's
this
what I'm saying.
I mean,
And this will be transitive because we can't check the condition of transitivity, no?
Yes.
yes.
In simple word, we can say that there is no element which is contradicting the condition for transitivity. Okay. In this set, we don't have any example which is contradicting the condition, right?
Okay, ma'am.
So we will directly imply this is transitive. If there is some example, then it will not be transitive. Okay.
Ma'am, let's say we have a set of 1, 1, 2, 1, 3 only. So in that case,
1,
it would be it would be a identity relation, right? No identity.
No.
No,
This is
No, ma'am, it is not symmetric.
How it will be identity, ma'am?
Transitive relation.
This is not
Not
identity.
Not
This is
identity.
not reflexive.
No, ma'am,
But this is symmetric.
Yes, it will be transitive, but it will not identity.
Yeah.
I'm not saying
Only
this, ma'am.
transitive.
I'm saying that
Only
what if
transitive.
we have only
Only
two
transitive.
elements?
Yeah, sorry. This is
Only
not,
transitive.
yeah. This is not symmetry. It is only a transitive relation. Okay.
Oh, okay, ma'am. Got it. Okay.
Because we don't have anything to check which can contradict the condition. But we don't have 3, 1. So directly we can imply it is not symmetric, right?
Okay, ma'am. Got it.
Okay. So any other doubt with this relations?
Ma'am, if 1, 1 only, then it will identity, reflexive, and as well as transitive relation. Only
No.
1,
No. Not reflexive.
Because in order to identity, we need all the tuples, same tuples. AA should be like, it will contain AA for all A belongs to A.
Yes,
This is
ma'am.
for identity. Okay. For reflexive, A will be in R for all
But-
A belongs to A.
And some other elements can be there.
Yes. So can you check what is the difference?
Ma'am, why is it not identity?
Because we don't have 2, right?
So why do
There.
we need 2? It's enough now. 1 is
No.
itself
What is
reflexive,
the
symmetric,
All the
definition?
elements
transitive.
will be set.
What is the definition for identity relationship? A such for every A belongs to A. We are taking the set as 1 to 3.
Okay. If we take set that.
So we need all the A for all A belongs to A. That means we need 1, 1, 2, 2 and 3, 3 else as well.
Okay.
Yeah, ma'am,
Correct?
got it. Yeah, right.
But for being reflexive, this identity relation is a subset of a reflexive relation, right? That
Yes,
means
ma'am.
A should be in R for every A belongs to A, but it is not the exact set. There may be some other element, some AB.
Every identity relation is a reflexive relation.
Yes. This was the relation between this. If it is an identity relation, then it will be a reflexive relation, but not the converse. If it is a reflexive relation, then it may not be identity relation. Fine?
Yes, ma'am.
Okay. So any other doubt?
No,
Ma'am,
ma'am.
just I want to confirm if just only 1, 1 is symmetric and transitive.
Just only 1, 1, right? Yeah.
Yes.
So it will be
But
symmetric. It will be transitive.
yes, thank you, ma'am.
So any other doubt? Any other queries?
No, ma'am.
Ma'am, is that is a reflexive?
No.
Yeah, ma'am, that's
Same
my
here.
doubt.
It is not even identity. How can it be reflexive?
Okay, ma'am. If it is identity, then it is reflexive. If it
Yes.
is not identity, then it is not reflexive,
Not
ma'am.
reflexive. Yes.
Okay, ma'am.
No. Sorry.
Ma'am,
If
you
it
just
is,
say
if it
wrong.
is not identity, then it may be reflexive. But it is, if it is
May be
not
reflexive.
identity,
Ma'am, it is just like a reflexive relation must have an identity relation
yeah,
within
yeah.
it.
Yes,
That's
yes.
only the deal
Yeah,
we are
yeah.
talking.
It's a
Reflexive relation
subset of that.
must have an identity. If it is identity, then it will imply reflexive, but not the converse. Okay.
Yes, ma'am.
Yes, ma'am. Yeah.
Yes, ma'am. So, are you clear with it?
Yes, I'm
We
clear.
maybe deal with some other example. Suppose we have our A as Z. Let us define one relation R1 equals to pair tuple belongs to Z such that 4 divide x minus y. You know this notation, right? That means
Set difference.
x minus y equals to some constant into 4. Okay?
Yes, ma'am.
Yes,
This
ma'am.
is our first relation. This is our second relation. X y belongs to z such that x plus y equals to 2. So whether R1 is equivalence like
No, ma'am, it can't be because R1 can never be reflexive.
Reflexive, yes, ma'am.
If
why?
we take the reflexive, then 0 in the denominator.
Divides 4, no?
2, 2.
I just wrote
2
it.
minus 2 is 0.
This
4
notation
divides
means
4.
no.
Vertical
See,
pipe.
this notation means 4 divides x minus y. It is
Yeah.
not in the denominator. Okay.
4 can divide 4, no?
Then 4 divides 0. Does it make sense?
Yeah. Any integer divides 0, right? We can take
Yes,
k
ma'am,
as
correct.
0.
0 by
True.
4.
0 divided by 4
0
is
by 4.
fraction. Yeah.
Yeah,
Yeah,
it
0
means
divided
0
by
by
4
4
is
only.
0.
Yes, yes.
Okay,
Not
then
0 by 4.
It is 0.
If we take 2, 2, then
0
it
is
is
divisible
0.
by 4.
Yeah, 0 is divisible by 4. or 4 divides 0. Okay. So
Yes, ma'am.
in order to check whether it is reflexive or not, this is a condition that xx should be in R1 for every x belongs to Z, right?
Yeah.
So x minus x equals to 0 and it is 0 into 4, right? So this is satisfying this condition. So it will imply xx belongs to R, right? R1. That means it is reflexive. Clear?
Ma'am, can you repeat once again, ma'am, please?
Yes, ma'am.
Here we have R1. So R1 is xy belongs to Z such that 4 divides x minus y. That means x minus y equals to some constant term into 4. The definition is clear, right?
Yes,
Yes,
ma'am. The
ma'am.
definition is clear, ma'am.
Yeah. So now we want to check whether this is a reflexive relation or not. So in order to check reflexive, what we need this condition, right? Xx should be in the relation for every x belongs to Z. This is the only condition for being reflexive,
Yes, ma'am.
right?
Yes, ma'am.
So,
Yes, ma'am.
so if we take, that means if xx belongs to R1, that means xx should satisfy this condition, right? That is what we need to check.
Yes, ma'am.
If I take x minus x, that means we are simply taking x instead of y2, right? So x minus x is 0, right? And we can
Yes, ma'am.
express 0 as 0 into 4. When there is any, if we have any integer, it will always divide 0, right? We can express 0 as 0 into any integer, right? Here we have specifically 4. So 0 is 0 into 4. That will imply, because it is satisfying our condition, so it will imply that xx belongs to R1 for every x belongs to Z. From here, we can imply it is reflexive. It's clear?
Clear, ma'am.
Clear.
So it's clear to everyone, right?
Yeah.
Yes, ma'am.
Okay, ma'am. Okay.
So what about symmetry? Is it symmetric?
It's not symmetric.
Right.
Symmetric only.
It is
Not
symmetric, ma'am.
Yeah, it is symmetric.
20
It is
comma
symmetric.
16
Is symmetric.
it works out, and also 16 comma 20 also divisible by 4.
So if we are trying to prove something is happening, we are satisfying this, we will not use any single
ma'am.
example. Okay.
Correct.
We will prove it generally. Okay.
So
The
there
thing
is
is,
two
when
equations.
we want to contradict something, then one example is enough to contradict anything. Okay. But if we want to prove something, then we need to prove it generally. Okay. So if it is symmetric, then for any xy belongs to R1, our aim is to show that yx belongs to R1 too, right? This is our aim. Correct?
Yes, ma'am.
Yes,
So we
ma'am.
have, this is our aim, right? So we can prove it generally. How? What is the process? We will start with x1 belongs to R1. That means x minus y will be some constant time 4, right? According to the
Yes.
definition. Right? So
Yes,
what we
ma'am.
can do, we can take minus as common, then it will be y minus x, right? This is some constant time 4. We can multiply minus over there, then it will be minus k into 4, right? So it is again a constant, right? Some k
Yes,
dash.
Yes,
So
ma'am.
we have y minus x equals to some k dash into 4. So it will imply y comma x belongs to R1, right?
Yes,
So we
ma'am.
started with
Yeah.
any xy belongs to R1, then we imply that yx belongs to R1. Fine? So
Yeah, ma'am.
this condition is now satisfied, right? And we prove it generally, right? So this relation is symmetric. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So that is how we can check whether it is transitive. What we can say. Is it transitive?
Yeah, it's transitive as well.
Yes, ma'am. It
Yes,
is
ma'am.
transitive.
So how can we prove it?
By
How to
general
prove it?
method.
Yeah. So what is the general method? We will simply start with our first condition, right?
X,
If
Y is element of R.
and yz belongs to the relation, right? So our aim is to show that xz will be in the relation, right? This is our aim, right?
Yes, ma'am.
In order
Yes,
to
ma'am.
show it transitive. So we have this. From this, what we can imply? X minus y equals to some constant time 4 and y minus z equals to some constant time 4, right?
Yes, ma'am.
So we can simply add these two equations, right?
To relate.
Yes.
Addition.
Yeah. We can simply add this two, then y will be cancel out. Then we will left with x minus z equals to k1 plus k2 into 4, right? So this is again a constant integer.
It
So
is
we will
transitive.
get x minus z equals to some constant into 4. So xz will be in the relation, right?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
So it is
So then it will be equivalence relation, right?
yeah, right.
Yes.
Right. So the relation became reflexive, it became symmetric, and it became transitive. So it will be a equivalence relation. Okay. So it's the example fine with you?
Yes,
All of
ma'am.
you are clear
Yeah,
with the example,
yeah,
right?
Yes, ma'am.
Yes, ma'am. Yes.
Clear.
Yes, ma'am.
Very good. Yeah, very good. So what about R2? What was our R2? This was our R2. Let me write it again. So our R2 was whether it is reflexive. Is it reflexive?
What is that? X plus y is equal to what? Yeah, ma'am. This is reflexive.
Reflexive only, ma'am. Addition is reflexive.
Yes, ma'am.
Why?
Ma'am, is that 2
0,
or
0
0,
plus
ma'am?
2, and, yeah.
It is 2. It is 2.
So, okay.
0 plus 2 and 2 plus 0, both are 2.
I just said if you want to prove
General
something,
method. Yeah,
you have
yeah,
to
general
do
method.
Ma'am,
general,
it will
not
give a
example.
constant, ma'am. X plus x is equal to 2, then 2x is equal to 2, then x is equal to 1. It will give a constant, ma'am. Is
Yes.
that correct?
So if we see x plus x equals to 2x, right? If it is 2, then it will imply x equals to 1.
Yeah, ma'am.
So if x equals to x not equals to 1, suppose let us take x equals to 2. So is x
Then not possible.
then 2 belongs to R2. Is the statement right?
No, ma'am.
No,
No,
ma'am.
not
This is
possible.
wrong, right? So we have some example 2 which is not in R2, right? So is it
Yes,
reflective?
ma'am.
Yes, ma'am.
No, ma'am.
No.
It is not
It is
reflective.
not.
So we get a example which is contradicting the condition for being reflexive, right? There is many element in Z such that this tuple XX is not in the relation. So immediately we can imply it is not reflexive. Fine?
Yes, ma'am.
Yes.
Is this symmetric?
Yes, ma'am. It is
Yes, ma'am.
symmetric.
It is symmetric.
Yes,
It is
ma'am.
symmetric.
It is clear, right? If
X plus
XY belongs
y, y
to
plus
Yeah, it's
x,
symmetric.
both are 2.
So
Yes,
y
ma'am.
It
plus
is
x
symmetric.
equals to 2. So it is symmetric, right?
Hmm.
Transitive? Is it transitive?
No, ma'am. I think because there is example like 2 0 and 0 2, and when we combined it, like it's 2 2, and it will not exist, I think.
Yeah.
Not transitive.
It is not transitive, it is only
Is not
symmetric.
transitive.
Yeah. Very good. So it will imply 2 doesn't belongs to R4 because 2 is not equals to 2. 2 plus 2 is equals to 4, right? So
Ma'am,
it's not.
there, ma'am,
I
you
think
haven't written it right.
0 to 2 and 2 to
0
0.
to and then 2 0. I think.
Yeah, I
Yes.
mean,
Yes.
Very good. Same order doesn't matter here, no?
No, ma'am. I mean 0 2 and then 2 0.
Yeah.
There
That is
two.
fine.
I
Yes.
actually have written the 0, 2 two times. So it
There
should
is
be
no
2,
problem.
0.
Yeah, there is no problem. Oh, acha, I wrote. Okay, sorry.
For transitive rule, ma'am.
Yeah. Now
Yes,
is it fine?
Yes, ma'am.
Yes, ma'am, it
It
is.
is.
Then the argument will be 0, 0 does not belong to R.
Yes, we can check it here also, right?
Okay.
0, 2 and 2, 0. Also, we can take 2, 0 and 0, 2. So 2, 2 is not there. Also, 0, 0 is not there. Okay, both the things are correct.
Yes,
If we
ma'am.
write that 0, 2 and 2, 0, and also we can write it as 0, 2, 0, 2, right? In this case, we will arrive a contradiction with 0, 0. In this case, we will get 2, 2 as our contradiction, right?
Yes, ma'am.
So, ma'am, in this case, we should choose 0, 0, right?
Anything you can do, no problem. Order doesn't matter here. We can get the contradiction with both 2, 2 and 0, 0. But only one thing is fine for us, right? If we get one example, then we can directly conclude it is not the case. It is not transitive. Okay? Even if suppose it is the case that 0, 0 belongs to R2, suppose, for example, just suppose, then also it will be a contradiction because of this element. Okay? Am I clear with my what, or I need to explain it?
Yes, ma'am.
It is okay, ma'am. It is clear.
Yeah. So
No,
both
ma'am, it is clear
basically what
already.
I want to mean, both the elements 0, 0 and 2, 2 should be in R2 in order to be transitive. Okay.
Okay.
Okay. So what is the conclusion? It is not reflexive, not transitive, but symmetric, right?
Yeah, ma'am, only symmetric.
Yeah. So if you have any doubt, you can ask.
Clear, ma'am. No doubt.
No, ma'am, it is clear already.
So it's clear to all of you, I guess. Okay. So we can move to
Yes,
the
ma'am.
next. Yeah. So we can move to the next topic. Which was function, right? So what was the formal definition for function? Suppose f from A to B a relation. So what was function?
It's a special type of relation in which every element in domain is connected to every element in codomain.
Where domain is not repeating.
Or
And an
only
element is a set
Sorry.
of way and only one image of
Every
its
element in
existence.
domain is connected. And it should
or
have
or
been
You are
connected to
using
only one image. There should be
in
only one image for
Element
each.
should have a unique image.
Yeah,
each
unique
element
image.
of the domain should have a unique pre-image. Unique image, right?
Where domain is not repeating.
Means each domain is exactly mapped to only one codomain.
Yeah. Unique means exactly one element in the codomain. And each element in A is also an important thing, right? So suppose we have A and B. We have 3 elements here. We have 2 elements here. So I'm giving you 2 examples. This is example 1. This is example 2. Suppose this element is mapping to this. This is going to here. Okay. And this is here. This going to here. And in this case, we have this one. And in third case, suppose we have something like that. So what is function? Which one is example for a function? Which one is not?
2 and 3 are
Only 2 is the
is
function. 1 and 3 are not function.
Okay, let us discuss one by one. What about 1?
No.
not one.
Not
Why?
a function.
It's mapped to 2.
Because each
2
have
are
a
mapped
two.
to
First
only
element
one
is
B.
mapped
Pre-image,
to
ma'am.
two elements, right?
It has 2 pre-image.
Yeah. It has
So it is giving 2 output at 1
it
input.
has two it has 2 image, right? Not pre-image. This is the image set. Okay. So the first element has 2 image here, right? So this is not a function. Yeah, you are right. What about the second one?
It is a function.
It is a function.
Yes, ma'am, it is a function.
And what about the third one?
It is
No,
not a
ma'am, it's not a
function.
function.
Why?
Third element is not mapped.
Third, yes, ma'am. In A,
This-
third element is not mapped.
Yeah. So it's clear that each element in A and has a unique element in B. The 2 word is really important, right? So you know, all of like the concept of being function is clear to all of you, right?
Yes, ma'am.
Yeah. So we can move to 1 function and onto function. So what was the mathematical definition for 1 function?
X1 is not equal to X2. Then function will not be equal.
Yeah. If X1 is not equals to X2, it will imply f of X1 is not equals to f of X2, right?
Yeah, ma'am.
So this is from our domain and this is from our codomain. And what was the mathematical definition for onto function?
range is equal to
Range equal to codomain.
Yeah. Range equals to codomain. That means simply we can also say if we take any element from the codomain, then there will be some element in the domain such that image of this element is exactly y, right? This is the mathematical expression, right? So we know if a function is 1 and onto, then we will imply the function is bijection, right?
Bijective.
Yeah. If a function is bijective, then immediately we can say it is invertible, right?
yes.
Yes, ma'am.
So, if we have a
Can
function,
we can scroll up the page, ma'am?
Yeah.
Ma'am, what is that opposite E sign?
Okay, that means there exist.
Oh, okay, ma'am.
There exist. Okay.
Okay,
That
ma'am.
means there is some element in A such that f of x equals to 1. Fine.
Okay, ma'am.
Yeah. Okay. So suppose is a function. This is a function, right?
Yeah, ma'am.
Is this a function?
No, ma'am.
No.
Why?
Horizontal line test not
vertical line.
Horizontal line test, right? Here
It
if we
is a vertical test, ma'am.
vertical test.
Vertical line field.
Vertical line
no
test.
vertical line test, right?
Yes,
So
ma'am.
this for this element x, we have 2 images, different images, right?
Yes, ma'am.
One is this, one is that, right? So this is not a function. So is it a function? For example, 1.
Yes, ma'am. One is a
Yes,
function.
ma'am.
It passes horizontal line test.
Yeah. Yes. If we take any horizontal line, it will cut the line once, right? So is it onto and is it 1, 1?
It is
Yes.
not 1, 1.
It is
Let us
not
first talk
1, 1,
about
ma'am. It is
It
not
is also
Not
1,
1, 1,
1.
not 1, 1, ma'am.
It's 1, 1.
Because it doesn't pass the vertical test.
Sure.
It's not 1, 1 because two values are coming
It is on.
on horizontal.
There are 3 elements here: x1, x2, and x3, for which the images are same, right?
It is
Yes,
not 1, 1, ma'am. Horizontal test
Not
phase.
1, 1, ma'am. Yeah, clear no.
Horizontal test.
So this is not 1, 1. Okay.
Yes, ma'am.
So suppose this is our function up to that. There is no more extension. And our codomain is the whole real line. Okay. Suppose the whole real line is our codomain. Then is the function onto?
No.
Why?
No.
Yes, yes.
Because the
At
range
this
is not.
point, there
Curve
is
is
no
not
yeah. It's
going
not covering
beyond.
whole the line, right?
Yeah.
Yes.
After that this was the range, right? It is the range. Let me use a different color. This is the range, right? This is the range. And
Yes, ma'am.
the
Yes,
whole
ma'am.
white
It is
line is the codomain. So range is not equals to codomain here. That means this is not onto, right?
Ma'am, can you please explain once the onto again, ma'am?
Okay. So in order to be onto, we need the range is equals to the codomain, right?
Yes,
Right?
ma'am. Yes,
So
ma'am.
here we are taking the codomain as whole real line. That means the whole y-axis. This is our codomain. Okay.
Okay, ma'am.
But our range is the yellow portion only, right?
Okay,
Which is
ma'am.
clearly a
Okay.
subset of our codomain, right?
Yes, ma'am. Yes, ma'am. Yes. Thank
So
you.
this is not a onto function. Okay. So are you clear with this example?
Yes, ma'am.
Yes, ma'am.
Ma'am, basically what happens when it fails the vertical line test?
Okay. So if we a vertical line test is to check whether it is a function or not, and horizontal line test is to check whether it is 1, 1 or not. Okay.
Okay, ma'am.
So if we take a vertical line here, okay, then we are looking for the images of some point here. So suppose we have x here, and if we take a vertical line at the point x, then we can see this cuts the curve at 2 points, right? That means for the point x, we have 2 different images. That means one point is going to 2 different images, 2 different points in the codomain. Okay. So it will imply it is not a function. Fine. So
Yes,
yeah,
ma'am.
everyone is clear right now?
Yes, ma'am. It
Yes,
is.
ma'am.
Can you
Ma'am,
show
I have a
example?
question, ma'am.
I have a can you show example where the codomain and the range are different?
Ma'am, I want to ask something, ma'am, about this graph.
Can you show an example where the range and codomain are different?
Okay, I will give examples also. I will surely give examples. Yeah, if someone has some doubt with the graph, you can ask. What was your doubt with the related to the graph?
Yeah, ma'am, I want to ask about this graph.
Ma'am, you said that it is not 1, 1 and not on 2, but it is a function. Then
Yeah, it is a
what
function.
we will identify it as a function means how we will separate it out.
Many one function. ma'am.
Yeah, it will be a many one function. It's not 1, 1, it's not on 2. Okay.
Okay.
So then we know what a quadratic function is, right?
Yes, ma'am.
For the quadratic function, we have a general form which is fx equals to
ax square plus
ax
b
squared
plus c.
Ax square plus bx plus
Yes,
c.
ma'am.
right?
Yes, ma'am.
So we know
Yes,
this
ma'am.
is the curve. This is the of a graph for a parabola, right?
Yes, ma'am.
So the
Yes, ma'am.
parabola naturally look like
It is
this.
a upward parabola, ma'am.
Yeah. So it
Yes,
whether
ma'am.
it will be upward or it will be downward, it depends on the constant a, right? If a is positive, then the
Yes, ma'am.
parabola will be upward, right?
Yeah.
If a is
Yes.
negative,
Yes, ma'am.
then the parabola will
It
be
will be downwards.
downward, right? So
Yes, ma'am.
if we have some upward parabola, that means we can like if we have some graph like this. So this point is the minima, right? The minimum value. At this point, we will get the minimum value of the graph, right?
Yes, ma'am.
Yes.
And we cannot
Yes,
talk
ma'am.
about maximum as it is going to infinity, right? So maxima doesn't exist here. Suppose we have something like that, then this will be the maximum, right? And here we cannot talk about the minima, right? It is
The
going to the
minus b by 4 is the maxima or
It is
minimum.
maximum value.
yeah. So this is
Minus
for
b by
this type
4a
of
or 2a.
parabola. Yeah. Minus b by 2a, I guess. So this is the
2
minimum
is
value
4.
and this is the maximum value, right? So and what we know that this is the vertex for a parabola, right? And
Yes,
if we
ma'am.
have
Yes, ma'am.
equation of a parabola, then we know the coordinate for a vertex is minus b by 2a,
2a.
therefore minus b by 2a, right?
Yes, ma'am.
Yes, ma'am.
So this is the vertex of a parabola, right?
Yes, ma'am.
So this will be a maxima if a is negative, right?
Yes, ma'am.
And it
Minus
will
b
be
by
a
2a and f of minus b by 2a.
so here this is the x coordinate for the vertex, right? If we have
Yes, ma'am.
x coordinate, then how can we find the y coordinate? After putting the value instead of x, right?
Yes, ma'am.
Yeah, ma'am. Yeah. Clear
Because if
now.
we have a function, what is the graph? It's the movement of these points, right? The graph is basically movement of these points, x, f, x.
Yes, ma'am. Clear now.
Yeah. So we can find minima if a is positive.
Greater than 0.
Greater than 0.
Fine.
Yes, ma'am.
So I guess it's now clear to you.
Excuse me, ma'am.
Huh.
Ma'am, I think we skipped Venn diagram.
Okay. So you need, if you have doubt, you can ask Venn diagram for set theory, right?
Yes, ma'am.
Okay, I will cover it. No problem.
Ma'am, in that like maxima minima concept,
Uh-huh.
I had a little doubt. I mean, that
Yes.
minus b by 2a. So in order to find the minimum value, we'll
Mhm.
be first finding that minus b by 2a, and then we'll be putting that value in the function to get the minimum value, or that minus b by 2a will be the minimum value.
No. The minimum value will be no. At this point, we will get the minimum value. Okay. I mean, what I was trying to say that at this point, we will get the minimum value. then we can
Okay,
put
so in
it
order to
and
find
then
the
we will
minimum
find.
value, got it, ma'am. So like
Yeah.
minus b by 2a will be the point at which we'll be getting
Yeah,
that
yeah.
minimum or
Yes, yes,
value.
yes. Yeah.
And that, ma'am, f minus b by 2a
Then
will be
it will be the minimum value. F
oh,
of
got it, ma'am. Got it.
and the coordinate
And ma'am,
is this.
okay, and ma'am, if the a is greater than 0, then
If a is greater than 0, then we will if a is greater than 0, then we will have some upward parabola, right?
Yes.
For
okay,
some
ma'am.
upward parabola, we can find the minimum value. And if a is less than 0, then we will get a downward parabola like that. Then for that, we will get a maximum value. That's why I wrote maximum if
Oh,
a less than 0 and minimum value if a greater than 0. Fine.
and ma'am, like one more thing, like in both the cases, whether a is greater than 0 or less than 0, we'll be using this same minus b by 2a to find the
Yeah.
minimum or maximum
Yes,
value.
yes, yeah.
Okay,
This
ma'am,
formula
got it.
is fixed for greater than 0 or less than 0, no matter. Here we are not
Okay,
taking a equals to 0, so we don't have any kind of disturbance there, okay?
got it, ma'am. Okay, thank you.
A is not necessarily like a is necessarily not equals to 0 here because we want a quadratic function, right? So the coordinate of x square will be non-zero, right?
Okay, ma'am. Okay, thank you.
Ma'am, second week was section formula and all that. Straight line, coordinate system, area of triangle.
Okay, yeah, coordinate geometry, right? Yeah, I missed something, yeah, right. So, if I guess up to that, it's clear to you, right?
Yes, ma'am.
Yes.
So in week 2, I guess we had, really sorry, I missed it.
Ma'am, I think, ma'am, this week 2 content is basically formula based, ma'am. Week 4 content will
Yeah,
be more
this is
helpful. If you,
basically formula
yeah.
based. I will just touch it. I guess someone may be in need of this, so I will just touch it. No, I will just take 10 to 20 minutes for week 2 content.
Ma'am,
So in
discuss
this,
the determinants, ma'am. Please.
yeah, I will.
Condition for determinants.
Yeah, sure. Yeah, I will discuss. Quickly, I will
Yes.
discuss. So in the
Yes.
coordinate geometry, we have seen that we have a coordinate. This was our Cartesian coordinate, right? So here we know how to determine the signs of the points, right? It was our positive, it was negative, positive,
Negative.
negative, and positive, negative, right? All of you are aware about that. So in this case, first we learned that how if we have any 2 points in the Cartesian coordinate, if we have any 2 points P and Q, so we know how to measure the distance between P and Q, right? That means length of the line. This is the shortest distance between P and Q, right?
Yes, ma'am.
Yes, ma'am.
So suppose the coordinate is Q1, Q2, and the coordinate is P1, P2. Then we will get the coordinate of this point, right? So what is the coordinate of this point? This is Q1, Q2, right? Coordinate of this point is P1, Q2, right? Because the x-axis is same to this and the y-axis is same to this line, right?
Yes,
so we
ma'am.
are taking y-axis of this point and x-axis of this point. So the coordinate we get, now we can find the length of this line and length of this line, right? Then we can use the Pythagoras theorem and then we will find the distance, right? If it is C, it is A, it is B, then we know that C squared equals to A squared plus B squared, right? Using the Pythagoras theorem, right? So what is A here? Length of this line, right? Which is Q1 minus P1, right?
Yes, ma'am.
Right? And what is B here? Length of this line?
Is,
Which is
Q2 minus P2.
P2.
Yeah. Now we have the value, so we can calculate the value for C, right? So using Pythagoras theorem, we can determine distance between any 2 points in the Cartesian coordinate, right? Then we can move to representation of line. We know what was the general equation for a line, right? Ax plus by plus c equals to 0. It was the general equation for a line, right?
Yes, ma'am.
And what was the slope? M equals
Minus
to
a by b.
Minus
Minus
a by
a by b.
right? It was the slope. So from this general equation, we can find the intercept form also. So we can simply simplify it. Y equals to minus a by b x minus c by b, right? And simply
Yes.
if we take minus a by b as common, we will get x minus d, where d is some c by a minus c by a, right?
Yeah, ma'am.
Yeah. So m equals to this, so we can directly put m here, we will get this. So this was our intercept form for a equation of a
So,
line,
ma'am,
right?
slope intercept form.
Yeah, this was the slope intercept form, right? So from the general form, you can find the slope intercept.
Ma'am, can you just repeat once more, ma'am? Couldn't follow you.
We are just simplifying it. We have the general equation. For a general equation, what we know that the slope was minus a by b, right? And from here, we can
Yes, ma'am.
arrive to this line just by arranging the term, rearranging the term. Then we are taking minus a by b as common. Okay. Then we will get this form.
Got it, ma'am.
Right? So now, so
Got
from
it,
the
got it, ma'am.
general, so from the general equation, we arrive to the slope intercept form, right? So there is all the forms are basically interconnected. That is what I wanted to show you. So again, we know that if we have two points, then using this 2 point, we can find the equation of the line which passes to these 2 points, like which is 2-point form.
Hello.
Yes, ma'am.
Hello.
Yes.
Ma'am, can you just explain about slope intercept form graphically actually? So what is that slope intercept form? I got to know the derivation, how it has been derived. No, actually, what
Yes.
does it mean?
So
Slope
we are
intercept
just
form.
we are just arranging the term, nothing more. And like we know this is the slope, right? So
Ma'am, can
if
you
we
just
just
put it in a
represent it, yes.
ma'am, can you just put it graphically actually? Just take Cartesian plane, and then can you just draw the diagram so that we can understand that? What is the
Not
slope intercept form?
it's not a graphical thing. The thing is, we have a function and the graph will be same, whether it is in general form, whether it is in slope intercept form. Okay. The graph is constant. The graph will be same for both the form, general form and slope intercept form. There is no change in the graph. But
It is a way of representation now.
yeah, it is a way of representation. Okay. Sometimes we need to do some mathematical calculation, and for that we want some more easy term, right? So we want some different kind of representation. That is why we need some representation. But the graph will be same for any form, any representation. Okay. If we have a line ax plus by plus c, we can draw the graph for the line. And if we can represent the graph in the slope intercept form, and the graph will be again same. There is no change in graph. Okay.
Ma'am, I'm getting partially. I'm getting it now partially. Just something like can I draw one curve, and then can I draw one straight line which is touching that line? That is called slope intercept form.
What
Is
I'm
it called?
trying to say, just see. If we have this kind of graph, suppose x plus y equals to 1. So this is a line, right? Like this. So we can express this as minus x plus 1, right?
Yes.
So the graph for this line will be again the same. No change in graph. We are just rearranging the form, the representation of the equation. Graph will be same. There is no problem with the graph. Okay.
Yeah,
So
yeah,
this
ma'am.
is
That
so this
yeah,
is
that
in general form, and this is in slope intercept form. This is the difference.
ma'am, that is not clear. But when you say intercept means where it is getting intercepted. This line, will it intercept any other no line?
No. It's
It
don't
will
take it
intercept
like that.
on
It's just
y-axis.
a
E is the y-intercept, na?
It will intercept
E
on the
is the
y-axis.
y-intercept, then it will intercept on y-axis.
yeah. Also, you don't need to find the like word by word meaning in that sense. Okay. You just like keep it in your mind, the form, the name. You just need the representation, what you can use for solving any problem. Okay.
Okay. So my problem here is until we get that core concept, we can't apply it in anywhere. So we don't know. So we know this, but the problem here is we don't know where to apply. In what condition and what formula to be applied is the confusion. So if we know that slope intercept form, then
See,
we can understand that
there
yes.
is
Application is in questions, na? Solve question, applied.
yeah, that is the thing. There is no particular type of problem in which you can apply this. You will get some problem. Then you have to choose what is the form which is more like easier to conclude something. That is what there are some 3 to 4 forms are given here. Okay.
Okay.
So then we have 2 points form. If we have given 2 points, then we can determine the equation of the line, right? Which is x minus x1, y minus y1, x2 minus x1, y2 minus y1. We can rearrange the term, no problem. There are so many expressions, but which is coming from this equation, right? So it was the 2-point form. I don't remember the exact name. Probably it was 2-point form. So it was the equation of a line which passes through this 2 point x1, y1, x2, y2, right? So let us solve some.
Ma'am, are you sure that this equation is correct?
Yeah, I just said you can rearrange this equation according to you, but which is coming from this. Okay. We can rearrange this, no problem.
Y2 minus
Whatever.
y1 divided by x2 minus x1 is the slope, na?
Yeah, this is the slope. We can
And this or the reciprocal of this.
we can write it as like that also, right? Y2 minus y1, x2 minus x1. We can rearrange it, no problem. Huh? So this is the slope.
Ma'am, what you have written, ma'am, which passes one line which passes that, what is that?
This 2 point, which
Okay,
passes this 2 point.
Okay, 2 points.
Passes through this 2 point, okay?
Actually, in the book, we will get the formula like y minus y1 divided by y2 minus y1 into m
Okay, so
into x2
what
minus
I said,
x1.
what I said, you can rearrange it, no problem. We can bring this term here and this term here, right? Okay. So this term is like more feasible for me. That's why I always wrote this in this form. So you can rearrange this, no matter.
Yes, ma'am. This is easy to remember.
Yeah. That's why I used to write this, because it's easy to remember for me. Okay. So what is in the book, this is also correct, and they are basically same. No problem. Huh? So suppose we have given that 3 points. A line L1 passes through these 3 points, and another line L2 passes through this 3 point. Okay. So what you have to do, you have to find the value for m and n. What is the value of m and n? Try to solve it, then we will discuss.
Where is M and N?
Here we have given that the line L1 passes through this 3 point and the line L2 passes through this 3 point. In another word, we can say these 3 points are collinear and these 3 points are collinear. So from this, we have given data. From this, we have to calculate the value of m and n. Okay. Try to solve it. Try to find the value for m and n. Write your answer on the chat box, okay? What is the value for m and n? Can anyone unmute yourself and say what will be the method? What is the method we can use to solve the example?
Yes, ma'am. First,
We can form the
we will
equation of line from the 2
and
points given and then solve the equation for.
equate
Yes, right?
L1 is
So you have to do
L1
this.
is
Yeah. So
yes,
what
ma'am.
is the equation for n?
L1 is minus 3m plus 4n divided by m plus n, and y is equal to 1n divided by m plus n.
Yeah.
And for
So what is
L2,
the simplified one?
one second, ma'am.
4
To simplify.
by 1 minus 3 minus 3 minus 4 minus 4 minus 3, right? Which is 1. So this is x minus y equals to 1, right?
Yes,
Right?
ma'am.
And what
Yes,
we
ma'am.
have that m in this point is lying the line, right? So it will satisfy the equation of the line. That means m minus n will be equals to 1, right? Similarly, what is the equation for line 2? It is x plus y equals to 1, right? That means m plus n equals to 1. So we get two equations. Using these two, we can now solve. So it will be 2m equals to 2. That means m equals to 1. And it will imply n equals to 0. So this is the value for m and n. Is it fine?
Yes, ma'am.
Okay. I guess you don't have any other doubt with this. It's fine?
Okay, ma'am.
Okay. Yeah. So these were the three type of representation for a line. I guess you are clear with the concept. So you can again move to the quadratic function. I guess it was your week 2 content, right?
Quadratic equation is week 3, ma'am.
Yeah, yeah. But the coordinate geometry and representation line and different forms of representation of line, it was your week 2 content, right?
Yes,
If I'm
ma'am.
not wrong.
Yes, ma'am.
So I
Yes, ma'am,
guess
week 2.
yeah, so I guess we covered the week 2 portion, right?
Ma'am, we just had an intercept
Ma'am,
form too.
SSC is left, ma'am.
Okay, so it essentially was the like I didn't discuss it. It was the like error, and we have to take the error and then square it and sum it. It was nothing more than that, right?
Yes, ma'am.
Square it.
And can you solve one question of that?
I don't have any question in my mind right now, but if you have anything, you can like take a screenshot and post it on the chat box so that we can solve it. There are so many questions in your activity question or practice assignment, I guess. You can take any one of that and post it in the chat box. We will solve it. Is it fine?
Yes, ma'am. Ma'am, we also had an intercept form too. Like, will you be revising that too, or?
I revised the important things, so I don't need I need to cover all the small things, right? Do you
Okay,
need
ma'am.
to need me to cover this, or then if not, then we can move to the next one.
Okay, ma'am.
Yeah. But my aim is to clear your doubt. If you have any doubt, I will definitely discuss it. If it is not that much like important concept, then we can skip it, right?
Yes, ma'am.
Ma'am, can you just slightly discuss on angles formed between two lines? That is the theta and phi, that part.
Okay. So that we can discuss, like we can do with the help of the slope, right? So simply we have two things. If we have any line, then we can if we have two lines L1 and L2, then we can have the slope, right?
Yes, ma'am.
So we had some conditions over the slope, and using that we discussed what will be the angle between these two, right? So if it is parallel, then the slope were equal, right? And if the line were perpendicular, then the multiplication was -1, right?
Minus one. Yeah, ma'am.
If it is perpendicular, then the multiplication is. So there was a general formula using M1 and M2 using tan theta, I guess. So you can
Ma'am,
find.
I have that formula. I'm just asking, ma'am, in which condition we can use, we will understand that we have to use that one, that concept I'm asking.
Okay, what do you mean by like in which condition you can use it?
Ma'am,
Like
I'm
if you
asking about
want to
the
find
angles.
the yeah. So if you want to find the angle, then you can apply it, right? Otherwise, you don't need to focus on it. This is
Ma'am,
this is
suppose,
what yes.
ma'am, in the formulas, it is one side it is for one it is minus and one it is positive. There only I get confused, ma'am.
Okay. So the thing is, it depends. It sometimes depends on the rotation, right? If we have theta equals to positive something, that means if the rotation is positive something, that means always it's a anti-clockwise rotation. That means in this direction. Okay.
Okay.
And if it is negative, that means it is a clockwise rotation. That means in this direction. So, like suppose what we mean, suppose we have two lines like that. Okay. So this is an angle which is in anti-clockwise
Anti-clockwise.
direction. Also, this is
Okay.
an angle which is in clockwise
Clockwise
direction.
there. Uh-huh.
Right? So it's just like if we have a positive and negative sign, so it will generally imply the whether the direction is in clockwise or anti-clockwise. So
Ma'am,
generally,
anti-clockwise means positive.
no, yes. Anti-clockwise means positive. So generally, it's we take the positive direction which is in anti-clockwise direction. So naturally, we take the theta, the angle as in the anti-clockwise direction. Okay.
Okay, ma'am. Okay, got it.
Okay. So let's get back to the quadratic function. So general form of a quadratic function was like that, right? So what was the slope?
Minus
What is
a
the
by
slope?
b.
2ax plus b.
I'm asking for slope.
Yeah, 2x plus b.
2ax plus b.
So it's simply if we have f, then f dash is slope, right? If we apply some point, then its slope at x now. Okay. So if we have f, what will be f dash? It's 2ax plus b, right? So this is the slope. So for quadratic equation also, we had one more form which is called intercept form, right? Right? You
Yes,
all
ma'am.
are familiar to this form, right?
Yes, ma'am.
So why do we need to why do we need to express some equation from the general form to intercept form? Can anyone explain? Like what is the importance? What can come to our mind first?
We can find the roots of that equation easily.
Finding the zeros.
Right. Very good. So if we have some quadratic equation in the general form, so it may be, we may face some difficulty to find the root from the general form, right? We need to do some calculations and all. But if we have the intercept form, we will easily find the root, right? It will be directly x equals to minus b by a and minus d by c, right? So yeah. So what we need that we have a quadratic equation in the general form. Then from general form we can express it as in the intercept form, right? And it's vice versa. Like if we have an intercept form, we can express it in general form, right? So one
Yes,
thing is
ma'am.
clear. If we have intercept form, we can simply multiply the terms. We know how to multiply to polynomials, right? So we can multiply the terms and we will get the general form. Again, if we have the general form, we can get the intercept form too, right? So for example,
Yes, ma'am.
just look at a quick example. So if we have 2x plus 1, this is equals to 0. Suppose this is our given quadratic equation and we want to express it in the intercept form. So suppose that means this is equals to this for some ABCD that I don't know, but we need to calculate the values of ABCD, right? Yeah. So
Yes, ma'am.
what we can do, we can simply multiply it. Then it will be AC x squared plus AD plus BC x plus BD, right? Then we can compare term by term. If we can compare term by term, then we will get AC equals to 1, AD plus BC equals to 2, and BD equals to 1, right?
Yeah, right.
So simply we can solve this, then we will get A equals to B equals to C equals to D equals to 1. Fine. So we can express it as x plus 1 into x plus 1, which is,
And we can go by midterm splitting too.
yeah. So there are so many methods. This is one method. We can simply equal it, and then we can compare the coefficient from both sides. Then we can solve the equation, and then we can get the values for the arbitrary function, arbitrary constant. Then we can express it in the form. There was another method called FOIL method, right? This is midterm method also, middle term factor, right? So the FOIL method was, if we have something like that, then the FOIL method, according to the FOIL method, multiplication of this two term, that means coefficient of x square and the constant term, this is ABCD, right? And this is equals to multiplication of these two terms,
Yes, ma'am.
coefficient of x, ABCD, right? So
It's another.
using this, we can also solve it. So for example, if we have some 5x square minus 13x plus 6, we want to use the FOIL method to solve this. So what we can do? We have multiplication of these two terms as 30, right?
Okay.
Right? So what we have to do? We have to express this minus 13 in such a way, in addition of two constant, in such a way such that multiplication of these two terms will be 30 again, right? Correct?
Yes, ma'am.
So what is simply coming to our mind? It can be minus 10 minus 3, right?
Yeah.
And
Which
6,
is minus 30. And also minus 10 into minus 3 is 30, right?
Yes, ma'am.
So we'll take minus 3 minus 10. Then what we can do? We will simply split the equation using this. Fine. Then we will get the form. We can take 5x as common, then we will get x minus 5, sorry, x minus 2 minus 3 as common, then we will get x minus 2 again. So it will be x minus 2, yeah, 5x minus 3, right?
Right.
So yeah, this is another method. That is how we can express the general equation in form of intercept form, right? So there was another
Ma'am,
method. Yes.
like in the lecture, the professor actually gave the intercept form in such a way, like for this same equation, he wrote like 5 into x minus 3 by 5 into x minus 2. Like he did the factorization in the same way, and thereafter he took 5 as common from this one to represent it as intercept form.
See, you can do anything, like in any way you can write it, but the thing is finally you will get this factor. The factor is same, right?
Like the basic idea would be to write a quadratic equation into an intercept form. We just have to factorize it, right?
Yeah. This is the basic idea. You can do it anywhere. Finally, the factor will be this.
Okay, ma'am. So basically, the professor actually wrote it in such a way, like a into x minus b into x minus q. Yes, ma'am.
Yeah, so basically he had a coefficient outside A. Doesn't make a difference.
Yeah. That is, you can take 5 as common and you can express it in that form. So there is no problem in that. The thing is, like ultimately the outcome will be same. Which method seems to be more easier to you, you can use this one, okay? The
No, ma'am,
underlying
sir
method
actually
is same.
took 5 in the end, not in the beginning. The end itself.
Okay. That is no problem, I guess. He did it in another way, but the underlying method was ultimately the same, right?
Yes, ma'am. The method was exactly the same, but in the end,
Yes.
he actually took this 5 as common. So
Yes,
even
ma'am,
if we
because
modify that 5, then
intercept
we'll
form
get
is actually like a into x minus p into x minus q. That's why he took 5 as
right,
common.
right.
Yeah,
It
that
just
is no
differs in
problem.
representation, I guess.
Yeah.
Yes.
Yes.
Write it
Just
as x
because via
minus 3 by 5
representation.
then.
Yeah. Yes, so no problem. Can take here 5 as common, then it will be x minus 3 by 5. So it is ultimately the same case, right? So when we equal this equation as 0, so we will get these two factor, these two will be 0 individually, right? So if you take
Right.
5 as common, 5 is a particular constant, right? 5 is not equals to 0. So we can cancel the 5 out, right?
Right.
We just take simply, then it will be this x minus 3 by 5, which is equals to 0. But 5 is not equals to 0, clearly. So it will again imply x minus 2, x minus 3 by 5 equals to 0, right? So we will get the root again the same. The roots are same ultimately. The method is same. Fine?
Different ways to represent the same thing.
Yes. This is the different representation. You can take the constant outside. You cannot take the constant outside. I don't think there is no meaning to do one more extra step. So you can directly equal it as 0 and you can
Okay.
directly find that. Okay.
Okay.
Right. So there was another form which is completing the square, right?
Yes.
So every equation is not a perfect square, right? So in the first case, I took this equation. It was a perfect square, x plus 1 whole square, right? But in the second case, it was not a perfect square. So this is again another method which we can use to solve a equation, right? So if we have any arbitrary equation, we can do some little adjustment with the equation so that the equation will become a perfect square. And using this, we can solve this equation, right? So for example, if we have, suppose plus 10x minus 24 equals to 0. So clearly this is not a perfect square, right? Right? But
Yes, ma'am.
Yes.
what do you know? What do we know that we can express 10 as 2 into 5. So we can make the equation as perfect square if we had there 25, right? We are taking 25 here. Then what we have to do? We are taking an extra term here. Then we have to balance it. So we have to take minus 25 also. We have to subtract 25 also. Then it will be again the same, right? Right? We are just rearranging the term. We are just adjusting the term according to our situation. So it will be now a perfect square. X plus 5 whole square equals to 49. Right? So now what can we do? X plus 5 equals to plus minus 7. So it will be x equals to 2 minus 12 deducting. Right?
Pranod, can you please turn off your mic?
Please mute yourself. Okay. So that is how we can calculate the root of the equation using the completing the square method, right? So using the help of this formula, we arrive to a new formula, which is if we have the equation, then directly we can calculate the rule with the help of this formula. Right? We can get this formula using this completing by square
Yes,
method.
ma'am.
So it is described in the lectures also. So I'm not doing the proof right now. I guess all of you are aware about that, right? Sometimes we can call it as
ma'am.
Siddharacharya rule, okay? Yeah. So this term, we call this term as discriminant and we denote it as D, right? So if this D, D equals to D square minus 4AC. So there are three possibilities for the number, right? It can be greater than 0, it can be less than 0, it can be equals to 0, right? So if it is greater than 0, then we had real and
distinct
distinct
roots.
root. If it is less than 0, then we have complex root, right? And if it is equals to 0, then we have repeated root, right?
Equal.
Okay. So I guess it's clear to you, right?
Yes,
Depending upon the discriminant, we can talk about the nature of the root, whether it will be real, whether it will be complex, or it is repeated, or it is distinct. We can make the like any comment about the nature of the root of the quadratic equation. Fine. So if you are fine with that, then we can move to the polynomials. Is it okay
Yes,
up to
ma'am.
now?
Yes, ma'am.
Yes, ma'am.
So what we know, a polynomial is polynomial in X. It is A naught, A1, X1 plus dot 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 sum AN Xn. This N belongs to natural number, right? Or some natural number. And this N is called the highest degree.
Ma'am, the quadratic part is done.
Yeah.
Ma'am, but I don't think you have told the vertex of the equation.
She did in
told
the
about
starting minus b by 2x.
Yeah.
Oh,
I
okay,
already
okay.
discussed about it.
Okay, sorry for that.
In before the coordinate geometry, I already discussed about it. Okay.
Okay,
If
ma'am,
you
sorry about
missed
that.
it, you can find the live streaming in YouTube. You will get it.
Okay, ma'am. Okay, ma'am.
Ma'am, actually, there was a concept of this irrational roots, and so that I had a little confusion in that.
What?
Ma'am, there was a concept of irrational roots.
Irrational
So,
root.
yes, ma'am. So, if you could please explain
Discriminant
that.
less than 0.
Complex roots.
If the discriminant less than 0, then we will get a complex root. That means simply here we have minus b plus minus root over d by 2a, right? So if d is less than 0, that means root d will be some iota into some number, right?
Right.
So it will be a constant term because we are getting an iota here. Okay. So because here we are considering the real, we are working on the real line. So we'll not consider the complex root here. Okay. So if the
Okay, ma'am.
discriminant is less than 0, then we will get a complex root. And if there is one complex root, the another root will be conjugate to this number. You know the conjugate, right?
Yes, ma'am. Like the irrational roots are conjugate of each other.
Yeah.
Okay, ma'am.
So we need not to bothered about the complex root because here we are working with the real line only. So here our case is just for discriminant greater or equal to 0. Okay.
Okay, and ma'am, like just a little suggestion I'm asking. In the end term, the questions from the quadratic equation would be like tough or they would be easy.
No, the
Like,
questions, all the questions are moderated. Okay. They are not tough, not so easy, I guess. But all the questions are moderated. If you are clear with the concept, you can definitely like attain the questions. Okay. What you have to do, you have to just clarify all the concept. Then you have to solve the problems. It is
Okay,
enough if you could solve all the activity question, all the practice assignment, graded assignment, all the example, all the question in the exam will be similar to this.
Ma'am, can I ask a general question? Ma'am, will we get weekends after this end term?
yeah, definitely 15 days.
Yeah.
15 days.
Yeah.
Thank you, ma'am.
Yeah. It's probably Ford and Huffman.
Okay,
So
ma'am.
we'll
Okay,
have
ma'am.
TA sessions or etc. during those times, or
Yes, ma'am.
it'll be
I
like
also
complete
saw
off.
in the calendar.
There may be, I'm not very sure about it, but there may be some sessions, but I'm not very sure about it. But there are no like instruction session, I guess.
Yes, ma'am. I didn't
And for
saw the
doubt
May be
clearing,
instruction.
there,
there
but
might be.
instruction session there.
And for doubt clearing, there might be, right?
Yeah. If you
Like, ma'am, in September itself, we can get admission for the second term, right?
yes. I
Thank
think
you,
by
ma'am.
the end of the September.
Okay, ma'am.
Yeah.
Ma'am, I have sent a question in the chat box. Can you please check it out once?
So what is the question about?
Ma'am, actually, it's about the Venn diagram.
Okay. So I will discuss this in the last of the lecture probably. Let me finish this. I will probably
Okay,
take a
ma'am.
maximum of
Yeah, sure.
half an hour. Let me just cover the polynomial things. Then we will. Okay.
Absolutely.
So let's do the quick revision portion. As all of you already know, I will not spend more time on it. So we can express it in this form also, right? Where I equals to 0 to n. So this is called exponent, which is basically belongs to natural number. This is called coefficient. That we all already know, right? So we need not to spend more time at it. So also, you all know how to plot the graph of a polynomial, right?
Yes, ma'am.
In this
A
section, I have a
factor.
problem.
Yeah. Yes. What?
Like in the graphing of polynomial, I had like problems.
Okay. So yeah, you can ask your doubt. We will discuss it right now. Okay. So we have some basic things. If we have the power, the exponent as some linear, that means 1, then we will get at that point, the graph will simply cross the point. If the exponent is something even, then it will bounce back at the point. Sorry. At the point. Okay. And if it is odd, then the graph will cross the point. And okay. So it was some simple thing which we know. And then we can use the end behavior of some graph and the constant term y-intercept. Using all those factors, we can plot graph for any polynomial. And also from the graph, we can talk about some least degree, turning point and all, right? All of you are aware about it, right?
Yes,
So
ma'am.
let us just solve one, two quick example so that with the quick revision. So suppose we have x minus 3 square, x minus 1 cube, x plus 2 equals to 0. Okay. So how will be the graph? 1, 3, and at minus 2, we have the roots, right?
Yes, ma'am.
So at 3, the power is even. That means, and also we can check the end behavior. As x tending to infinity, f of x will be tending to, this is our f of x, okay? It will be tending to infinity, right?
Yes, ma'am.
Yeah. So if x tending to minus infinity, what we can say about f of x?
Minus infinity.
Minus
Yeah.
infinity again.
Why?
Plus infinity.
It will be plus infinity, right? Because it's
Yes,
positive,
ma'am.
it's negative, and it's negative, right? So it will be positive infinity, right? So this is
Yes.
the n behavior. That means we have something here upward, something here upward. Now, at x equals to 3, the power is even. That means it will be something like that here, right? So this will be something like that. Now at the point 1, this is cube. That means this will be something like that at that point, right? Clear? And at the point minus 2, this is 1. That means it will simply cut the point. So it will be, the graph will be like that. And this point will be, this is the y-intercept, right? So if we take x equals to 0, we will find some constant. Then we can calculate the value of the y-intercept, right? So that is how we can plot the graph for any given polynomial, right? Is it clear?
Yes, ma'am.
Ma'am, can you explain the extent to infinity, that concept again once more?
So we can check the n behavior here. When x is going to infinity, fx is going to infinity. That means here x is going to infinity, right? Fx
Yes,
is
ma'am.
also going to the positive infinity. This is the positive infinity for y-axis, and this is the negative infinity for y-axis. If it were going to negative infinity, then this will be something like that. But it is going to positive infinity, right? So it will be something in the upward direction, right? And
Yes,
also
ma'am.
when x is going to the negative infinity, then again fx is going to the positive infinity, right? Here, this is the positive infinity. Fine?
Yes, ma'am.
Ma'am, can you please explain about turning point?
Yeah. So a number of turning point we can check. So what is the number of turning point here in this graph? It's 3, right? 1, 2, 3, right? Turning point means at that point, before the point, the graph will be something, and after the point, the graph will be changing its nature. So before the point, this point, the graph was decreasing, right? After the point, the graph became increasing. So this is one turning point. Similarly, at this point, here the graph was increasing, right? After this point, the graph became decreasing. So this is another turning point. Okay?
Yes, ma'am. Thank you.
Similarly, this point is one turning point. So I guess you now understood how to like plot the graph if you have given any polynomial. Okay? So suppose we have a graph like that.
Ma'am, that turning point kind of thing we can only find if we have a graph, right?
Yeah.
Okay.
Otherwise, we can talk about the maximum turning point.
Roots.
Not exact.
When we have roots, then we can
If
also
we
find
have
maximum.
if we have the graph, I mean if you have the any polynomial, we can check the maximum degree, and the number of the maximum number of turning point will be the maximum degree minus 1. Okay.
Yes.
But if we want to talk about the exact, then it will be better if we can like check the graph. So suppose we have this graph. This is one. This is another. So yeah. What is the number of turning point in the graph 1? Anyone?
7.
7.
Eight.
Okay.
7.
Let us count. 1, 2, 2, 3, 4, 5, 6, 7, and 8. Right?
Right. Okay.
1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 turning points. Fine. What about this one?
Yes.
5.
5.
So here, 1,
Nine.
2, 3, 4, 5.
5.
So there are total 5 turning points. Fine.
Ma'am, if the graph is going from decreasing to constant, then we don't consider that as changing point.
No. Because see, at that point, before this point, the graph was increasing, right? After this point is also the graph is also increasing. It's not changing its nature. Okay. What I said, it will be changing its nature before and after that point. But here, if we consider this point, after this point, the graph was increasing, and before this point, again the graph is increasing. So we will not consider this point. Okay.
Okay, thank you, ma'am. Got it.
Yeah.
Ma'am,
So
Ma'am,
that is
in the first graph, okay. No.
Ma'am, if you could explain this end behavior just shortly.
end behavior means this is our x-axis, right? This is our x-axis, right?
Okay.
So this is the end of the graph, right? So what we can check, this is going to infinity because this is infinity for y-axis and this is minus infinity for y-axis, right? So
Okay,
when
so we'll check
extending
with
to
respect to
infinity,
y-axis. Ma'am, we'll check this end behavior with respect to y-axis.
yes, because fx is in the y-axis, right? This is
Okay,
our
ma'am.
codomain. Y-axis is our codomain. So when we are checking the behavior for the function, that means we need to check with respect to the y-axis. Okay.
Okay, ma'am.
So for this graph, if we continue this like that, going to infinity, so it will be going to minus infinity as x going to minus infinity. Now is it clear? And as x going to infinity, this will be going to infinity.
Yes, ma'am. Now it's clear. Now, like there's one more thing. How can we find this end behavior from the equation given to us?
So
Like,
here, suppose we have the equation, right?
Right, ma'am.
So when extending to infinity, this, what about this? X is tending to infinity. Suppose we just put simply here infinity instead of x. Then this term x minus 3 will be again infinity, right?
Yes, ma'am.
So similarly, this term will be infinity and this term will be infinity. So fx will be tending to infinity, right? This is our whole fx. Again, if x tending to minus infinity, then x minus 3 will be again tending to minus infinity, right?
Yes, ma'am.
But here we have a even power. Then it will become positive infinity, right? Because minus will be cancelled out due to the even power.
Okay.
So here we have a x minus 1 will be negative infinity, but here we have a odd power. So that's why it will be negative, right?
Okay, ma'am.
Similarly, here we have again one odd
Now I
power,
got
so
it.
it will
Yes,
be
ma'am.
negative.
Now I got
That
it.
is how we can check the end behavior.
Yes, ma'am. Okay,
While
thank you,
plotting
ma'am.
the- Yeah. So what about the graph 1? What is the minimum degree? What we can say about the minimum degree?
Nine.
Okay, so let us check. It has 1, 2. All the intercept are linear here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So minimum degree is 9 here because we have 9 linear factors here, right?
Ma'am, could you please repeat what you said?
Here we have 9 linear factors. Here we have 9 linear roots, right? It has just crossed the point. Simply crossed the point, right?
Yes, ma'am.
That means we can express the graph as 9 linear factors. There may be something more than that, but at least there are 9 linear factors, right? Everyone is okay with it?
Yes, ma'am. Yes,
Yes, ma'am. Yes, ma'am.
Yeah. So the minimum degree will be 9.
Ma'am, 9 linear factors, what are you referring to?
That means this is a linear root, right? Just seeing the graph, you can comment on the nature of the root, right? This is a linear root. That means we have, suppose this is A, this is B. So we have x minus A, x minus B, and so on for all the points, right?
Yes,
so this is one linear factor, this is two, second linear factor.
Yes, ma'am,
That
got
is,
it.
in this way, we will get 9 linear factors. Okay.
Ma'am, if the graph would be touching at one point, then it would be the square or degree 2.
Yeah, yeah. As per the basic rule. So yeah, we can find the example in the second graph. So what will be the minimum degree here?
6.
10, ma'am. Okay, let us count. So for this point,
11.
the minimum, it will be minimum 3, right? For this point, minimum 3. The minimum odd, which is greater than 1. So for this point, it is the linear. So plus 1. For this, again, we will get a linear factor, so 1. For this, we will get 2 linear factor plus 1 plus 1. And for this, we will get 1 odd factor, which is 3, right? So this is the minimum degree. So are you not clear with the?
Please mark the points for which you are talking.
What?
Please
I'm
mark
talking
the
about
points.
I'm just talking about the x-intercept. Okay, this is one in x-intercept. Here the degree will be odd. Here this is 1. Here it will be 1. The degree is 1. Here the degree is 1. Here the degree is 1. Here again 1. Here again we will get some odd degree. And the least odd degree is 3. It may be 5. It may be 7. Anything. But we need to talk about the linear, the least degree, right? So we will get the least degree, which is 3, which is greater than 1 and which is odd 2. Fine?
Why greater than 1?
Because if it is 1, then it will just cross the line.
Okay.
We have something different picture for the linear case, right? So we will not consider 1 here.
Okay.
Yeah. And it will be minimum 3. It will start from 3. After that, we get that. Okay. So I guess
Could be minimum 4, ma'am. And it could be minimum 4 also.
no,
4 is
4
ma'am
is
is
a
talking
even number,
about
right?
odd.
4 is a even number. But if we
Oh,
are talking about
okay.
even number, then we will get 2 also, right? 2 is the minimum even number.
Okay.
Fine.
Yeah. Got it.
Okay. So do you have any doubt with this graph thing? And like if we have any equation, we can plot the graph and vice versa. If we have the graph, then we can at least make some comment, some important comment about the equation. So do you have any doubt? If you have, you can ask. Yeah, this session is being recorded. It's being live streaming on our official YouTube channel also. You can find it there. Okay, so all of you are fine with this concept, right? So we can move to the next one.
Yes, ma'am.
Yes, ma'am.
Then we had one, I think probably in, it was the thing in week 4 probably, right? In week 4, we covered these things about all things about polynomial. I didn't cover the multiplication and addition of polynomial because I guess all of you are comfortable with this polynomial.
Yes, ma'am.
Right?
Yes, ma'am.
Yes, ma'am.
Polynomial operation. Yeah. So I didn't cover it. So I guess it was whole week 4, right?
Yes, ma'am. Week 4 is
Yes,
done.
ma'am.
So it was from week 4. Now we can move to week 5, which
Multiplicity
was
of graph.
probably your exponential functions, right? in
Hello.
week 5.
Yes,
So
ma'am.
again,
Ma'am,
the
what is
general
multiplicity of
notation for the exponential function was
ma'am?
fx equals to, yes,
And what is multiplicity of graph?
multiplicity of roots. That means how many times the roots are
Yeah.
repeating. Okay. So here, if we have the the exponent, in this equation, if you have x minus 3 square, that means the multiplicity for 3 is 2. Okay.
It's repeated root, right?
Yeah. How many times is it repeating? That number is called the multiplicity of the root. Okay. Okay. So this was an exponential function, right? Where a was greater than 0 and x belongs to r, right? And we have seen we had two different cases when a was greater than 0 and less than 1 and a was greater than 1, right? Two different cases. At a equals to 1 also we can check, but it will be a constant function, right? Equals to 1. So this is not an important case. That's why we will avoid a equals to 1 case. So this was the two case when a was in the open interval 0, 1 and when a was greater than 1, right? So what was the nature? Anyone of you can unmute yourself and please.
Ma'am, when a is between 0 and 1, ma'am, it's decreasing. When a is greater than 1, it's increasing.
Yeah, so it was decreasing. So what we can do, simply we can plot the graph, right? When a was greater than 0, the graph was something like that, right? Correct?
Yes, ma'am.
Yeah. So it was tending to 0 and it was tending to infinity. That means when x tending to infinity, f of x was tending to infinity, and when x tending to minus infinity, f of x were tending to 0, right? Right?
Yes, ma'am.
This point was 1 because it is our y-intercept. If we put x equals to 0, then f of x was 1. So this is the y-intercept. So clearly we can check in this direction, x is increasing, right? X is increasing in this direction. And y is also increasing in this direction. So for this phase, it was increasing when a greater than 1. But when a less than 1, what was the graph? It was just opposite.
Mirror.
This type of thing, right? Right?
Yes, ma'am.
Yes, ma'am.
So it was when x was in the increasing direction, is when x was tending to infinity, it was tending to 0, right?
Yes,
So
ma'am.
what we can
Yes,
do,
ma'am.
if a is less than 1, greater than 0, that means a equals to some 1 by b, where b is greater than 1, right?
Yes, ma'am.
So a power x means 1 by b power x. That means b power minus x, right? So because of this minus sign, everything was just opposite to this case. So the graph was something like that. The intercept, y-intercept was again 1. So this was the graph for exponential function, right? So you don't have any confusion with the graph and the nature and all the things, right?
No. Yes, ma'am.
So what we know, if we take specifically e instead of x, then we would say it as natural exponential function or simply as exponential function, right?
Yes, ma'am.
Yeah. And from the graph, both of the graphs, we can use help of the horizontal line test and vertical line test. And from here, we can conclude about the range, about the domain and everything. So it was the domain, right? The x-axis were the domain, which is
All real.
the whole real
All
number, right?
real numbers.
And range is only the positive numbers.
Yeah, because it was tending to 0. The negative side is empty, right? So range was 0 to infinity. So if we take the function, exponential function from r to 0 to infinity, it will be a onto function, right?
Yes.
And from
Yes.
the horizontal line test, we can also check that the function is 1 also, right?
Well, also,
Yes,
it's a
ma'am.
bijective.
Yeah. So it's a bijective function. That means it is invertible, right?
Yes.
Yes.
So it must have some inverse. And we know
Logarithm.
what was the inverse, right?
Yes, ma'am. Logarithm.
Log A x, which is f inverse. Immediately after this line, what we can say about the domain and codomain of logarithmic function?
Ma'am, its range is R
Yeah.
and its domain is 0 to infinity.
Yes, very good. So as it is an inverse function of the exponential function, then the domain of exponential function become the range of the range or codomain of the logarithmic function, and the codomain of the exponential function became the domain of the logarithmic function, right? Just after seeing this, we can make
Ma'am, how
comment
to
about
find inverse of a function, ma'am?
what?
How to find inverse of a function?
Okay, so we define this logarithmic function
Can you
as
tell
an
an example,
inverse
ma'am?
of the exponential function.
Yeah.
Okay.
Can you tell a specific example?
Yeah, sure. So let us first just do some little bit thing with logarithmic function, then I will tell you how to find the inverse function. Okay. So what simple thing we know, if we have a function, then graph of the inverse function will be symmetric with respect to the line x equals to y, right? Correct? That we know, right?
Yes, ma'am.
Yes, ma'am.
So, so again, using this fact, what we can do about the graph of the logarithmic function when a greater than 1, then it is inverse function for a power x where a greater than 1, right? So the graph of this function will be symmetric with respect to the line x equals to 1 when a greater than 1. So when a greater than 1, the the exponential graph of the exponential function was like that, right? Correct?
Yes, ma'am.
So again, we will get something like that here, which is symmetry with respect to the line. And it is, because it is an inverse, we need not to check like putting the points and all here. We just simply we use the fact that it will be symmetry with respect to the line x equals to y, and we can simply draw the graph. Okay. This is log ax when a greater than 1. Fine. Similarly, for this case, we can draw this graph using this. Okay. Fine.
Yes, ma'am.
Yes, ma'am.
Okay. So it was your logarithmic function. Okay. Someone has asked to discuss some example. So suppose we have fx equals to x square. So what is the domain and codomain for this function? Let's talk about the domain first. Domain means if if you are taking something as domain, that means this f should be defined at each point of the domain, right? So
Domain R.
what R, right? And what is the
Real.
codomain?
To infinity.
0 to infinity.
Close or open?
Closed.
Right.
0 close and infinity open.
This was the domain and codomain, right? So this function is yeah, is it a 1 1?
No.
Suppose we want to, it is not 1 1, right?
No, it's not 1 1.
And 1.
Because 1 and -1 will have same image. So suppose we restrict the domain as 0 to infinity. Okay. Suppose this is our new domain and this is our new codomain. Then
it's on to.
It is 1 1.
It is 1 1 then.
It is 1 1.
Right?
I don't.
So inverse exists, right? Suppose we don't know what is the inverse. Suppose g is the inverse. That means g is some function from 0 infinity to 0 infinity, right?
Yes, ma'am.
And if it is inverse, then what we know, f compose g equals to g compose f was identity, right?
Yes.
Yes, ma'am.
This was the condition for being inverse. Now we want to calculate g, right? So we will put here f of g of x will be identity of x. This is x again, right? So f of, according to the definition, f of g of x is x. And f of x means x square, right? So it will be g of x whole square equals to x, right?
G of x is equal to x.
So now we can find the inverse of the function f. That is the rule. In this way, we can find inverse of any functions. Fine?
Yes, ma'am.
The general procedure using this, we can find inverse of any function.
Ma'am, in one of the tutorial video, it was given that we have to find g of f of x also. And if both are same, then only it is inverse.
Yeah. That is why I wrote this condition, right? Both are same.
Yes. Ma'am, but in our case, if we don't restrict the domain, then this won't be an inverse, right?
Yeah, because for if we want the inverse, the function have to be the 1 1 and on to both, right?
Yes, ma'am.
If
And
it
root
is not invertible, then obviously we will not get any inverse. In order to be invertible, we have to the function have to be 1 1 and on to both. If the domain was R, then function was not 1 1, right? So we have to make it 1 1 so that we can find the inverse. If we want the inverse, in this case, I wanted to find an inverse, but R was the domain of the function. There was no problem with that. But in this domain, the function was not 1 1. That's why I restrict the domain and I consider a new function with the restricted domain. Then the function became 1 1 and onto in this restricted domain. So then we can imply that the function is invertible, and that is how we can find the inverse of the function.
And ma'am, root x is not defined at negative x, na?
No, because then it will be a complex number.
That's all.
That is why we restricted this as 0 to infinity, right? So there is no negative number here.
If we have to find the inverse of a function, we could just equate it to y and then just find out in terms of y and then replace y with x, right?
Yeah.
Or we have to do all of this that you did.
No, you can do this. This is just a general procedure.
So both are correct. Yeah, I just want to confirm.
Ha.
Okay.
Yeah.
Ma'am, just one more doubt. Here we modified our domain, but in a question, if it is just given that R to 0 to infinity, then we should not modify, right? like 0 to infinity, we
No,
can't
no, no,
modify.
no.
And in
If
such
in
case,
the question there is something given in as a domain, you will not modify this. You have to take this as domain, and if the function is not 1, 1 or on 2 in this domain, then you will simply imply that the function is not invertible in this domain. You need not to restrict the domain and all. Okay.
yes, ma'am. Okay.
Yeah. This was just for example.
So if you didn't had modified the r here, then it's not 1, 1.
Yeah, it's not 1, 1 because for the negative one and the for any positive one, for 2 point we will get one image, right? For 1 and -1, suppose. Okay. For -2 and 2, both will be 4, right? The image, both will be 4, right?
Yes, it's not passing the horizontal line test also. We
Yeah.
can.
Yes. It's not passing the horizontal line test. Because see, the graph will be something like that, right? At the origin. So it will fail the horizontal line test, right? There will be 2 different images. But if we restrict our domain from this to this, then our new graph became this only. Then there is no problem with the horizontal line test. Then there is only one image, right?
Okay, ma'am. Okay.
So is it clear?
Yes, ma'am.
But if in the exam there is given some domain, you need not to like improve it and make the function as a invertible function. You need not to do this procedure. It was just for example. I just wanted to like show you that the function is invertible in some domain, but it may not be invertible in another domain. Okay, this is just for example.
Okay.
So I think it was the content up to week 6. That was my aim to cover. Now, if you have doubt, we can pick it up. Someone was asking about Venn diagram. So
Yeah. Could we do a few questions on Venn diagram?
Yeah, sure. If you have some question in your mind, please post it. Then we will solve it. Okay.
Ma'am, shall I post my doubt again?
Sure. Sure. There are so many chats, so many things, so I cannot find you. Just post it again. So the revision session was up to that. After that, I will cover if you have any doubt. Just to 10 or 15 minutes, we are already out of time. So.
Okay, I have posted.
I don't know why I cannot see your screenshot. Yeah, it's not. So I don't know whether it is but I got a question using the quadratic form, and it has given some value. When using this, we have to find the value of A. So it's not a question. We don't need to use the value.
Actually, I have posted it to you directly. Now I have posted it at everyone. So.
So there are so many questions. What I can do, I will give you a general idea about it, okay? And you have to solve it in your own. Because we already solved this type of question many times, right? So here, what is the general idea I can give you? We will get 3 different sets, okay? and they are given their cardinality. Okay. We have cardinality of all the sets. Also, we have cardinality of the intersections, right? If I am not wrong, then that is all the things are given there, right? Right? All the cardinality are given there, right? So what you have to do, you have to draw the Venn diagram. This is the Venn diagram. So this is suppose our set A, this is suppose our set B, and this is set C, right? So this portion, the yellow shaded portion, it's intersection of set A and B, right? Right? So this was the intersection of set B and C. And the red shaded portion was intersection of set A and C. Okay. And the white portion, this portion is intersection of A, B, and C. Okay. So when you have the cardinality, we can you have formula for A union B union C, right? Using these things. So you can directly use the formula. You can put the value there. You can find the cardinality of A union B union C, and then you can solve the question in this way. Okay, this is a general hint for solving the question. That is the main Venn diagram thing is. That is the main concept. Okay. We will get set. If there is intersection, you have something in which is common to both A and B, and which is common to both B and C and sim. And if there is intersection in A, B, and C, then you will get some portion common to all the three sets A, B, and C. Then you have given some set equations formulas. Using this equation intersection unions, you have to use this formula. You have to keep it in your mind. Okay. Always try to recall the formula. Using the help of this formula, you can solve the question. Fine. So what I guess, I think that much hint was okay for you. I think you can now solve this using this hint. Fine.
Yes, ma'am. But can you please look at the question also?
Hello, ma'am. Did you cover limits and continuity also?
No. Limit and continuity we'll cover in the next session. Okay.
Okay.
It's already week 1 to 6, I guess. So it's too much. Now, rest of the thing we will cover in next session.
And
Whatever you have covered from week 1 to week 6 in today's revision.
Okay, so
will this be enough for clearing the questions in the weekend?
Can you write your doubt in the chat box? Actually, you are not audible properly, or you can use your headphone.
Ma'am, somebody has sent a question regarding this Venn diagram. Could you just explain that?
Yeah,
you don't
yeah.
need to compute it. It's very
just,
simply, yeah.
See, I just gave a hint right now, right? So the thing is, what you can do, you can determine the set based on suppose like the post of data analyst. This can be one set. The student which are in the post of data analyst, and there are some there are some 105 candidates which are proficient in Python programming, right? So you can determine one new set B, suppose set B or suppose set P, whatever. for this Python programming, and again you can determine one set for this Java programming, and for C program. Okay, so we have three different type of thing here: Python programming, C programming, and Java programming, right? So we have some candidates who are proficient in this three programming set, right? So what we can do, we can make three different set. One set for the candidate who are proficient in Python programming, another for C programming, and similarly another for Java programming. Okay, so the students which are proficient in both Python and Java, they will be in the intersection of these two sets. Yeah. Similarly for Java and C, and Python and C. Okay. And the students who are like proficient in both all the three programmings, they will be in the intersection of all the three sets. Okay. Now, so that is how we can get all the cardinality here. Then you can use this set equation formula simply. Okay.
I just wanted to ask, like in the exam, this is I think of the qualified exam quiz one question. I was able to do it by using that A, B, C we use now. Variables we put in and then we simplify equations. I was able to do that. I just wanted to ask, like for questions like these exactly one, do we have a formula, direct formula, or indirectly we have to compute it?
No. See, you can directly compute it by using the Venn diagram. But I think it's not like if you are doing this to practice, then it's fine if you can calculate it using the Venn diagram. But in the exam, it's better to use the formula. You have the formula A union B union C equals to some summation of cardinality of A minus summation of cardinality of A intersection B and B intersection. That's it. Plus summation of plus cardinality of A intersection B intersection C. That kind of one kind of formula you already have, right? So
that is not exactly one.
Yeah, there are so 5 to 6 formula, I guess. Whatever question you will get in the examination, you can use the formula and solve the problem. Okay. You can solve the problem using the Venn diagram also, but there may be some silly mistake in that way, right?
That becomes confusing. Yes, you're
Yeah,
right.
yeah, that become confusing sometimes. So in the examination, you need not to take any kind of risk. So simply use the formulas to calculate it. Okay.
Okay. Yeah, got it. Thank you.
Okay. So I think we are running late, so we can close this session right now. If you have another doubt, I guess there will be another session for your doubt clearing. So you can ask your doubt in the next coming sessions. Okay.
Yeah, okay, ma'am. Thank you so much. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank
Thank you, ma'am.
Thank you, ma'am.
Thank you.